Hi guys. Can you hear me? And how's the sound quality?
Good evening. Yes, we can hear you, and sound quality is good.
Great. So I suppose we can start working on our things. As you have probably seen, I already checked assignments which were submitted, and I even placed marks. Okay, it might happen that some of assignments are not
Hello.
evaluated because it could happen that someone just placed them after I checked them. So it could happen. So if it's so for you, so guys, there will be a time when I will check them. Anyways. All right, so I suppose that we could take a look on some new materials and we can try another stuff in the Python. All right, so give me a second. I will open my Windows system on my computer and then I will share a screen. Yeah, we have some submission, some assignment which is not evaluated. Well, okay. Guys, if we were talking about the scissor chipper, um, okay, I will share the screen. Okay, I hope you can see that. But if no, just give me a sign that you're not seeing that. Okay, I have to put this bar somewhere. Let's say here. Okay, I'm not sure if you can see that or not. Okay, so maybe I will not open those marks because I'm not sure if it will be correct, because maybe some of you wouldn't like to how to say, share it with your colleagues. I mean your marks, and if your works are evaluated. The story is super easy. Um, how it happened? So let's maybe take a look on that scissor chipper definition, right? And I will maybe give you some comments and maybe a possibility to make an update. So, what was the working process of all this? So we have some text, right? And we literally changed the letters, the symbols, um, ASCII code, and since we changed that, we receive another symbol. But what I figure out when I was testing your assignments, so I figure out that somehow it happened that when I try, for example, to make a forward step in this encryption, let's say if we have D, then we receive E. Let's say one step forward. Then when I take the letter Z, I receive the next symbol in the ASCII table. But in the same time, if we are working with letters, right? Well, I suppose it was super clear that actually in place of some next symbol, we would receive maybe A, maybe B if we have two displacements. Let's say forward, right? Um, so um, so this is the maybe the only not kind of mistake, um, but something that has to be corrected for let's call that outstanding results. So that's why, if I'm not mistaken, I didn't place the highest marks, only because of this thing. But okay, it's fine. Anyways, if you would like, you can just make corrections. I would say that's on you guys. If you like, you can make a correction. Yeah, and about that assignment related to the calculator, so everything was really fine, if I remember correctly. And yeah, I just tested things which submitted, and actually results are pretty nice. The only thing I remember that, if I'm not mistaken, all of you found out the way how to execute the text as equation. Well, I would say a smart way, but you could even make a programming of all of those steps. But once again, it's not a problem at all. Okay, so let's take a look on something new. Well, today we will take a look on this Python and files in PDF. Literally, we'll take a look how is it possible to work with files. And maybe the next step, which will, which will happen next week, will be related to CSV files, Excel files, and others interesting things. Okay, so working with files, as you probably know, well, I'm sure you remember that in whatever programming languages, we actually can create some files as maybe output results, maybe some calculation results, and so on and so on. The same for the Python. Well, if I'm not mistaken, I have heard some sounds.
Yes, I had a question about the color codes in my Python. For example, I was using online DNB Python, and I was using like color codes, as you can see in a chat. And using it in a terminal in Windows in CMD, it doesn't work.
Yes, there is a difference. I would say there are not really much differences between different compilers, but yeah, maybe it had to be highlighted that different systems will have different functionalities, but it's kind of rare case. So what you did? So let's take a look. So you made the printout. You have the 33rd code. Okay, we can have it. Then decrypted text. Okay, then you have the text, and you trying to.
And I try to close the 33rd code to go back to the original color. As I remember, 94M is a blue color.
Okay. This looks tricky. This really looks tricky. Okay, let's do like that. I'm not really ready to give you any ideas because I wouldn't like to. Well, let's call it say a priori not fulfill things, right? Maybe I will just copy what you sent. I will maybe put that in the page. So maybe in notes. I'm not sure because there are a lot of strange things. I have here. Okay, where can I make a new note? Okay. Anyways, I don't really need these things, so I will just put it there. Okay. So maybe before the next time, I will take a look. Well, for some maybe common solution for different systems.
Okay, thank you very much.
The similar problems happens actually even with some another programming language compilers, because I remember that maybe approximately in the end of previous fall, autumn, right? So I had some classes related to C++, and unfortunately there were similar issues. So once again, there were some online services which are based on Linux, and surely most of us are using Windows systems, which is quite maybe easier for usage. Well, and we have differences in those implementations. Looks like codes can be run. Sometimes they can be executed, sometimes they cannot be executed. But even when it happens, we don't receive assumed results. But you know, it is what it is. And okay, so just to make a long story short, I will take a look on this before the next time. All right, now let's take a look what we have. So, okay, well, as you remember, before this class, we tried to communicate with the user using some printouts on the screen, asking the user to type some value. You know, then we use that value in some analysis, for example, putting the value inside the picture or anything else. So we use the input function for that purpose. And we can assume, okay, well, that's a pretty nice communication, but what could be much more interesting? Well, maybe saving some large portions of information in files. Okay, well, here we have that example we used previously. Well, we used input, and we could literally type whatever thing we like, and in most of the cases, that thing could be even, you know, calculated. And I can even say that there are even another types of inputs. For example, the raw input, which literally doesn't really analyze what you type, and you literally can type some information, some equations, which will not be even executed. So they will be just assigned as the text, well, as the plain text, as we call that sometimes. Okay. Well, I think this is super easy and super clear for us at this point. Okay, so the first thing we have to start with is opening files, closing files, and just understanding how we can work with files. And maybe before I switch to the next slide, I will ask you guys, what do you know about working with files, maybe using some maybe Java programming language or C++ programming language or whatever else programming language? What are key aspects related to the working with files? Maybe some ways to store information in files, maybe maybe something related to the way you save that information. So guys, tell me please, what do you know about working with files? Okay, maybe I will even open the chat just in case some of you would be quite shy to activate the microphone.
Well, basically not much.
Oh, okay. So you didn't have any maybe C++ classes related to that or any other programming language classes? No?
We had just one about data structures and the algorithms. So just opening a file, specifying the allocation, and closing it.
Oh, oh, okay, okay. Um, all right. Um, not really much, but okay. So, well, working with files actually assumes that we are working with a spatial object created in a system. In most of the cases, we call that a stream. So, well, a stream is in this case just a value. We can call it as the value streamer between the operating memory, so-called RAM memory, and the secondary storage, well, like hard drive. Okay, well, what's interesting, what should be taken into account while we are working with files? And this, by the way, works in a similar manner for a C++, just in case you maybe use C++ sometimes. So we have to have the file's name, and it could be a relative, an absolute path. So it's up to you guys which one you're using. But keep in mind that if you're using the relative path, so you have to a priori specify the current folder of your project. Well, I assume that you know a difference between a relative and absolute path. So because you have to know that. The next one is the access mode. So we can have the access to the files of with different purposes. So those purposes could be reading information, could be writing information. In the same time, it could be writing information and reading information in the textual mode or in the binary mode. And the difference between these two modes, the textual and the binary, means that when we save a data, we literally, for example, we are about to save value of 5. So this value 5 can be written as the text, so 5, which actually is a symbol which has its own ASCII number. And we already know a difference between the value and the symbol, right? So symbols have their own ASCII numbers. So that's the one way. Or we can just save a value of 5 in a binary form. So in most of the cases, guys, when we open maybe some exe files in a text, well, I'm no idea what to choose here. Maybe I will take some small exe file, for example, this one. So when we open them in maybe Notepad++, just textual, you know, we receive a lot of nonsense things here, and literally why we have them. Because actually information is saved in this exe files and other files using a binary mode, so it means it's not textual, so we're not seeing text. Well, if we have them, it happened by the random, I would say. So we have a lot of those things, and how do we get them? Literally literally all of information in exe file is just split it in groups of 16 bits, so mostly 2 bytes, and those 2 bytes are just represented as the text, as the symbols. So and we have the symbols. So besides this, or beneath this not really clear characters we have here, there is the binary code, which is just constructed, adding once and once again to the exe file some codes and values in a binary mode. So literally that's the common idea related to the binary format of the file. And we literally can write and read information from files in a such way. For example, a operating system reads information from all files in a binary mode, and depending only on a representation of data, we see that information as text or as application which is being launched. Oh, okay. So here we have those different ways of working with files, so-called modes. So opening in a binary mode, opening for reading and writing, opening for reading and writing in the binary mode, writing only in the binaries, opening for writing and reading, and actually if the file doesn't exist, so it will be just created, making the same in the binary mode, opening the file as mostly textual file. Well, yeah. So open a file in a textual mode for adding an information in the end. Same for the binary mode. Same for appending the values in the end of the file and reading the values, and opening the file for both appending and reading data in the binary mode. So as you can see here, we have quite a lot of those modes we are using for working with files. The next thing that when we create a stream related to a file, we can have access to parameters of that connection to the file, and this can be used as subvariables of the object when we have our instance of the class, and using the point, we just have an access to some maybe values, like sub variables, maybe we can call it that way, and some functions of the object. But I suppose this part is clear. Okay, well, what could be maybe a small example of that? So let's suppose, okay, and here we have that the Linux way of creating of that file, but you will just ignore maybe these lines, because in the Windows you don't need that. So what we are doing, we are opening a file, we are opening that only for the writing, and we literally see that the writing will happen in the binary mode. Okay, and we can have access to parameters, to some of parameters of this full variable. Okay. Okay, let's see what we'll receive in the end. For sure, I already gave you these results, which we'll get in the end. But anyways, let's try it on our own, like we do that all the time. So I will go for documents folder and Python, and maybe I will use this file, and I will override that file's data. Okay, that's great, and maybe I will even put that in in the chat, so you would be able to maybe use that on your machines if presentation is not opened on your computers. And I have to go for a CMD window. Okay, so here I have one, and I'm about to go inside this folder just to work in the folder Python b.py. Okay, what do we have here? Yes. Since we're using the third syntaxes, we have to use the parentheses. Yeah, we have to use the parentheses because now we're using the third version of the Python. Okay, anyways, let's see what we have. Okay, so we have the name of the file, we have a closed or not false, so it's not closed. We have the opening mode, which is known for us. Okay, and we have and we have some error related to a sort space parameter. Okay. So we don't have it in this version, but okay, so we can just ignore that. In most of the cases, this parameter is not really used. Okay, so anyways, as you can see, we can have access to some of information related to the file. At least we can always check if the file is still opened, already closed, and so on and so on. Okay, well, I assume this one is clear, and let's see if our text file is created. Okay, so as you can see, we have it, and it's being created because it didn't exist. Just as it was written in our slide, related to that writing mode. So if the file doesn't exist, then it will be created. Okay, so let's move forward. In the end of the working with files, we have to close them. So what we manage by that? Literally, when we open a file, in most of the cases, our application, our compiled code, registered in the system that the file is being overtaken by some process. And we cannot really maybe erase that or change some values. Well, I'm not sure how it will happen here because I don't, I didn't really try to this on Windows 11. Okay, so Windows 11 doesn't really hold information about that or doesn't block actions. But once again, it could be even related to the case that I have a bit modified Windows 11 just to fit my M1 processor MacBook. Because some of things are just not happening on the system. Okay, so let's make a step forward. So how the full process will look like. So we open the file, and in the end of the working, we just closing the file, and that's it. So as we understand, we have an opportunity to read information from files, as we did, by the way, for steganography examples, and we can write information inside, as we did it that time as well. So what we use the write and the read functions. For example, the write function, it reads an information in the file, and and if you're working on textual files, you have to remember about new lines, because new lines suggest specific symbols. For Linux, it will be a symbol number 10. For Windows, it will be for ASCII files, it will be symbol 13 and then symbol 10. For Unicode and UTF-8 files, it will be symbol 10 and then symbol 13. Sometimes in programming languages, it's enough only with symbol 10, but I would say it depends on implementation of programming language. So how that looks like. So we open the file for the writing, and we write the information inside, and we are closing the file. No. Okay, well, let's see what will happen if we will write information first in a binary mode and maybe then in a textual mode. Let's see, guys. I think it will be interesting for you. So let's have it here. Let's erase our file. Oh, okay, I already erased that. That's great. And let's run the script. Okay, what I have here. So I have a problematic here, because this version of Python assumes that I have to use the binary mode for I have to use bytes for writing the information. Well, that's a bit actually strange, because in most of the cases the text has just been converted to bytes. Okay. Maybe we can just take a function which we had in our steganography materials. I suppose we can take one. For example, this one, like a binary to text and text to binary. We can maybe place that in our codes. Like this one. I hope it will work. And we maybe can apply a text to the binary. A text to the binary function. And I will maybe activate the word wrap, so in my editor I would see everything. Okay, maybe in that way. Okay, let's try it again. Oh, okay. It doesn't allow to write an information. Well, that's strange. That's really strange. Maybe that's a version specific something. Okay, it doesn't matter. Let's just use the text. Because it's quite strange. It didn't need to happen actually. Okay, so we executed just the text writing. So we have this check on which information is just written inside. Okay, and as you can see, we have our text in a text file. All right, and we have these different lines here, and why we have them? Because we have the enter sign. So we have this symbol number 10, which is /n in well, in programming languages, in a lot of programming languages. Okay, I suppose this one is clear for us. Let's maybe make another thing. So the reading of values. Okay, well, reading of values can be implemented by the function read, and we can actually receive a data from the file. Surely there is a possibility to read a specific amount of values for textual files. For the files when we just have the mode R or maybe R plus, the main thing is it goes without the binary mode. So what we do, we specify amount of characters, and that's it. So let's suppose we are working with the same file as we created previously. Let's copy this code. Let's place it in our file. So, and what we will have? We will have the file opened. We have an information that we are opening 10, we are receiving 10 symbols, and we are printing them out. So in the end, we have to receive a quite small portion of information of the file. So let's see how that looks like. Okay, so we have this text. So we have Python is and actually that's it. So do we have 10 symbols here? 1, 2, 3, 4, 5. So literally we have 5 pairs of 2 symbols. Yeah, so overall 10 symbols. So literally that works. Okay, so sometimes when we are about to have a multi-access for the file, so both reading and writing, or maybe appending to the end of the file and reading of the file, we can actually go between symbols in a file. Well, it's something similar as we have, text, and we just put a cursor and we go between them. And we say, okay, where we will have our cursor from that part, we'll start reading the text. And let's say we put the cursor and we have a symbols after that cursor, like ing space is space and so on and so on. So in a similar manner it happens for files. When we apply a function seek. Okay, let's take a look on a case of using that. So once again, we will open our file. We will try to read values, and we will try to find out at which position our reading cursor stands on. Well, because once again, as I showed you on the example, when we read some symbols, we're even moving our cursor forward. So symbol is red, so that's it. So the cursor is after that symbol's position. Literally, that's how it happens. Like when we read the book. Once again, we see a symbol, we read that, and we go to another symbol, something like that. Okay, so what happens next? Okay, we can get the position, and in the same time we can set up at what position in the file will be located. So what we have, we have an literally an offset from the specified position, but actually I would recommend you maybe to use just the first parameter. Okay, so let's copy this code. Let's put it inside our file, and let's run that. So yes, the print should be just modified. Yeah. Okay. All right. So oops, what happened? What happened? Maybe I closed the file. Yeah, looks like I closed the file somehow. Okay, let's run that. Okay, so we have our text. We have a position at which we allocated in our file, reading that. We change that position and we print out 10 symbols after that position we are at. If we will make some modifications, for example, here we will go for 2 positions forward. And let's see what will happen. So right now we are located on the offset of the second symbol, and indexation starts from a 0. So so it means we are located before literally before the third symbol, because 0 goes for first, 1 goes for second, 2 goes for a third symbol. Okay, and as you can see, the first 2 symbols are just ignored. So because our cursor is placed before the letter T. So, and we took 10 symbols right after that cursor position. So that's the idea. I suppose it's super clear. Okay, we can have some operating system functionalities like creating the file, erasing the file, modifying its name, moving the file between the folders. All this is possible. Okay, and for that purpose, we'll need to have the library OS. Sometimes these things are called as modules. Okay, so we'll have to have that module in our code, so we have to import that. Well, as you remember, we previously imported the library Pillow when we worked with images. So we imported the library Softkinter library pack, and in the similar manner, we imported OS things. Okay, well, let's see how it will be possible to rename the file. And we had, if I'm not mistaken, this name of the file. No, double O. And let's say we will rename that to this file. Okay, so let's see what will happen. Okay, we have that. And as you can see, so the name was just changed, which is quite, simple thing. Okay, let's make a step forward. Removing the file. Okay, well, this part is super simple. So once again, we have just a small tiny function for that purpose. Okay, I will give this name of the file which already used. And let's run that. Let's see what will happen. Well, file disappeared. Surely there could be a big question. Okay, well, where's that file? Maybe it's just erased fully from the computer, or maybe it was just erased to the dust, so-called recycle bin. Well, we can check that quite easily. We can go to the recycle bin. Okay, maybe this one is not the best case. How to open that? I'm not sure how it should happen on Windows 11. Maybe I can just minimize all of Windows, and I can just maybe open this recycle bin. Okay, so as you can see, it's empty. So literally we erasing files in so-called the permanent delete way. Okay, I suppose this one is once again super clear thing. Okay, So we can work on folders, so we can create a folder. And by the way, guys, in most of the cases, at least from my experience, I can say that there is a huge need of creating some folders, just storing some data of applications. So this is a kind of a must-have in the apps. Creating some maybe temporary storages and so on and so on. Okay, let me be located in the same folder we have been previously. Okay, so as you can see, we have this folder test, which we had right there. Okay, so once again, super simple thing. Okay, a really interesting thing is this one. So, so you know, guys, when we work with files, we pretty often try to work with the relative paths. So, what's the relative path is? It's not an absolute path. So we can, for example, mention only the file's name without the full path. So literally, it means that that file will be searched in a specific folder. So I will maybe copy the code that literally opens the file and reads some information from the file. Let's say it will be this one, and I will just make I will maybe just make a small file with the info. Okay, so here we have that's name, and let's go for the this files creation. Okay, let's say it will be something this. Okay, surely when we will run that, we will have again error message, because I once again forgot about that we are using the third syntaxes, not the second. Okay, so we have text. In the same time, you know, if only our file would be located in the folder, we would need to specify the path to that file from this folder. So it means we would need to go to test folder. So we would need to specify here test, and then the slash, or maybe double slash, because sometimes one slash is just a kind of assumption that after that we will have some kind of control symbol like a /n, /t, /r, and so on and so on. So if we do that, you can see we still have an access. But in most of the cases, this thing is not happening that way, so we just have the relative path. And as you probably understand, it's impossible to open the file because it doesn't exist. So we have to say to the application that we are starting to work inside another folder. For that purpose, we are using this function, which is called the change current folder function, but it has kind of, you know, much shorter name, like a CHDR, like change. So this first is kind of ch button letter. So which literally is abbreviation from a change directory. Okay, well, we can open, we can use that. We can use our folder, and we will be using OS library. Okay, that's great. Okay, so what will happen next? Let's see what happens. Well, we changed the current folder. Nextly, we already started to work in that folder, just reading all files which I mentioned by just the name of the file. That's it. Well, I suppose this part is clear. And afterwards, what you will just do, you can actually go back, like you know, using some folders which is located in your current folder, and in the folders actually we always have two hidden folders. One is called one dot, which is the reference for to the current folder, and another one is two dots. So 2 dots is the reference for the upper folder in the hierarchy. So if we will do that, so as you understand, it will be impossible to read the file, right? Because in this folder there is no that file. So let's see if it will really happen, but it has to happen. Yeah. So you see, so working in that test folder, well, we have that file, so we have access, and going back to initial one, we are not having that, so it's not possible to print any information from that. So this functionality is super popular. Even besides the fact that from the beginning it looks like it's useless, it's not useless at all. Um, well, I can just say that from my personal experience. Okay, well, we can even get the current folder. Because sometimes it's not obvious for us where we are located, in which folder, or let's say which folder our app assumes to have as the current folder, and we can get that by using this function. By the way, we can even print that out. We can print out this data. So let's suppose before the changing the current folder, I will go for printing that, and I will do the same after changing the folder and after the going back, like this one. So let's see what we'll have in the end. So, well, as you see, guys, firstly we allocated in this folder, then we went to the task folder, then we make the step back. So here we have it. Well, I suppose it's kind of simple thing. Okay. Well, sometimes we need even to make such operations with data as removing them. For example, when you have some temporary folder in which you save information, and maybe after the user session this information is not really needed, well, then why to store some junk files in the system? It's not really needed. So we can use a remove dir function. So let's maybe try to use that. For example, before the change in folder back, we'll try to maybe erase that. But I'm not sure if it will give us any problems. Well, I suppose that there will be an error message because we'll try to access the reference to the upper element in the hierarchy when we just erase the folder. Well, I suppose we'll have some interesting fancy error message. Let's see. Okay. Okay, that's pretty interesting. All right. Well, what will happen if I will just have this line and nothing else besides that, like this one? Okay. Well, I will have that. The folder is not empty. So literally, we can try to um, use some parameters of this rmdir function, or we can just maybe go through all of the functions, but it will all of the files in the folder, but it will happen in the recursive mode. So in most of the cases, we will have a function that literally executes itself. Okay, well, it's an interesting thing. Well, how to do that? In the same time, we can use even one of another functions. I suppose it was in another module, that allows to erase both folders and files which are located inside that. For that purpose, we can use um, the library. Well, I'm not sure what was the name for the Windows systems. It was like the shell util or utils. I don't know, maybe util. And in place of rmdir, we could use remove tree. rm3. Yes, if I'm not mistaken, it was this one. And the only thing we are not using that from the OS, but we're using that from this library. Okay, we can even erase this OS library usage. Okay, let's see. As I said, I'm not sure if it will work in the Windows. Okay, so since we didn't have any error messages, I suppose it worked. Let's see. Oh yes, so that worked. So literally you can use that remove tree just in case you wouldn't like to create codes that just go through through files, erasing them. Okay, so well yeah, so this is the last slide of the presentation. Oh, okay, we have some 8 minutes. Okay, that's great. So let's see if we have something in the chat just in case. Okay, we don't have anything. Awesome. All right, so literally we tried all of this data, all of these things. So once again, let's go back to our modes of the working with files. So once again, we can read information, we can both read and write the information, we can only write the information in a file, we can write and read or create in the file if it doesn't exist. Next, we can open the file for writing the values in the end only. Or we can open that file for writing information in the end only and reading, for example, using function seek. And everything the same can happen, but only with working in binaries. Okay, I was quite surprised why the text is not just automatically converted to binary data. So maybe give me a second. I will take a look. I will maybe try to find out what specific was in this new version. Oh, okay. Okay, that makes sense. Okay, so I have no idea why, but in this version of the Python, there is an interesting way for writing a data inside. Let's take a look. No, not this one, but yeah, this one. Okay. So the interesting thing is that the bytes here could be shown as the following. So we have B before the text, and in the text we have to specify information in the binary mode. Well, the binary mode, as you probably know from maybe another programming languages, is a kind of 0, then X, then a number which represents the byte. Well, for example, /x, because 0 is not really needed in the beginning. Then we can have some information. which will be the binary in literally the byte information. Let's suppose we can have even something else, like I have no idea, maybe something this. And this data will be just written. Okay, well, let's see what we'll get in the end. So we have C3 and A9. Let's run that. Okay, so it happened, and we have our this for thing. And what we get here? Well, we got some symbol, and this symbol literally is the combination which is formed by those two addresses which were given. Well, actually, that's so that only think that maybe it's not really clear what we wrote inside. Well, let's suppose we'll just erase this data, and we will maybe write some symbol which is known for us. Maybe symbol. I have no idea. Maybe symbol 31 or something else. Okay, let it be maybe 21. Which has to be an exclamation sign. Well, let's see if it will happen. Let's run that, and let's open our file, and let's see if that will be an exclamation sign, but I suppose it will be. Okay, let's reload that. Yeah, exclamation sign. So let's check if it's really so. So we had 21 in the byte mode, right? Written as literally as hexadecimals, literally. So let's maybe go for the ASCII table. Let's Google that. I will maybe write ASCII table. Oh, okay, here I have something. Okay, and let's go for the hexadecimal 21. Okay, and we have it here. So you see, and that's the exclamation sign. Okay, so the only thing that you will have to make a transition between the text and this binary modes, which is quite easy to make. So you have to just have the ord from the symbol, from each symbol, and you have to write that in hexadecimals mode, and that would be great actually. Okay, maybe I will leave that well how to say, maybe on your shoulders, this modification, or maybe we can just maybe implement something okay, well how to have the text, and maybe make a conversion, or maybe how to write the set of those bytes. Well, maybe we can create the array. Nextly, we can have some functions that just make maybe we'll just make something like, I have no idea, 21, 22, 23, 24, let's suppose. Next, we can have maybe some another variable, which will be byte array function, inside which, okay, not this brackets, but this one we will give this byte array. Nextly, we will have some another variable, converting maybe this byte array to maybe so-called bytes data type. So B2 will be used in that way. And maybe we can just use that, for example, here. Well, this could be. Let's see if it will happen. Oh, yes. I suppose it happened, and we will have just some of those symbols. Okay, I'm not really sure how it happens that they are not recognizable. What do I have here? Okay, write bytes. Literally, literally that looks nicely. Okay, let me take a look. So we have the area of okay, understood. I use decimals, and the first two symbols are invisible, so that's why. We can try to use maybe some ASCII decimal ASCII values of some symbols. Let's say A, B, 67 is C, 68 is D. Maybe in this way, and let's run that. Yes. So you see this information is written in the binary mode, but since we are using the textual editor, each byte is being represented as a text. So and you can see we wrote the bytes inside, and in the end we see text. I will give you this code just in case you will need that, and I will maybe even put this. Maybe I will even put this thing in our materials. Just maybe making here a label. Okay, where was the label? I don't really see that. Yes, it's here, and I will maybe put it there. Yeah, something like this, just in case you will need that. Okay, guys, so I see that that's the time for us. Maybe there are some questions from your side before we'll finish.
Not at the moment.
Okay. Was everything clear for you guys?
For me, was everything clear?
Okay, what's about others?
Clear enough.
Okay, great. All right, and somehow I see that that not all of you are connecting, because I don't really see that you would be 9. So what happens with your colleagues? Because I suppose you have even some other classes. So how it happens? Are you usually 9 connected on classes?
Depends on the day, because today we have only one lecture. It's OOP review, so
most of the time 3 or 4 people.
Okay, I see. Yeah, well, in our case, we have only one class, and it starts at 6:40 because I just don't have an opportunity maybe to start it earlier, because I have previous classes finished 5 minutes till 6, so it's not possible just. Okay, so yeah, so that's the thing. Right, guys, so I suppose everything clear, and I can maybe switch off